Right, everybody, we're going to do a beta decay now, or beta decay, depending on how you want to say it. So, I'm going to just go straight into this. Don't worry about the ins and outs of this, because to be honest, you don't really need to know why it does what it does. You just need to know about the numbers again and what happens. So, just to recap, beta decay, we're going to represent it as a nice beta symbol with a 0 up here and a -1. And in case you couldn't remember, we call it a high speed electron. So it is a high speed electron, and we can represent it as just E-, or if you want to, the circle with a minus in it. It's entirely up to you. So that's our beta symbol. So the types of things that beta decay occurs in, the thing that you're probably going to see crop up the most is carbon-14. Now, I accidentally left that on the worksheet in last lesson, so I apologise, but thanks to the people that had a go, the people that left it out going, I don't know what you mean, that's fine. The people that did it as alpha decay, you know what, you've had a go, and I appreciate that. So, carbon-14, it's unstable, it's radioactive, and it's a beta emitter, all right? During radiation, it will, during decay, it will emit a beta particle. Now, I will go into what a beta particle is and where it comes from in the next video, so don't panic about it too much right now. We're just going to look at what happens when carbon-14 decays. So, let's have a little look at carbon-14. So, beforehand, so carbon-14, 6 protons. So, before the decay, we've got 6 protons, 6 neutrons, and we've got 6 electrons. That's going to bug me now because I did 2 capital letters and then I didn't do a capital letter there, and you not know what I'm like. So, carbon-14. So, in total, we've got a mass of 14. So, mass 14. Okay. So our beta decay occurs, and we're going to turn this into something else. So this time, our proton number is actually going to change. Our atomic number is going to change, and we're going to have something different, okay? We're going to have something completely different, but our mass is going to stay the same. So our mass number is going to stay the same in this instance. So we're going to turn this into something different. And that -1 that you see at the bottom here actually means +1. I can already hear you all groaning and saying, what? I don't get it. What do you mean? But you've got to look at it in the opposite way. So rather than it being -1 there, just think +1. So we write it as -1 because it's this electron. But actually it means +1 to the atomic number, and it means that we don't add anything to the mass. So what we get is we get nitrogen 14, 7 protons. We've now got 7 neutrons. Okay, so I'm not really fussed about the electrons in this case. I'm just thinking of the protons and the neutrons. The mass is still equal to 14. Okay, oh, I just realised that's not a 6, that's 8. I can't do maths because it's early in the morning. Sorry, guys. So, 6 protons, 8 neutrons, so that total mass is 14. And here, 7 protons and 7 neutrons, the mass is still 14. So look, we've gone down by 1 neutron. So the neutron number is actually -1. But the atomic number is +1. So what's essentially happened here is that this neutron has turned into a proton. So 8 and 6 has turned into 7 and 7. Mind-blowing? Maybe. Who knows? It's early on a Wednesday morning. So all you have to do in these calculations is make sure that your proton number increases by 1, so your atomic number increases by 1. Your neutrons will change. Your neutrons will decrease by 1. but your mass should remain the same because the protons and the neutrons will balance one another out, okay? So the mass should stay the same, all right? So let's have a little look at how we would write this out if it was an equation. So we've got carbon 14 with our 6 protons, and that's going to decay into our beta particles. So we're going to write our beta particle in first, so we know what type of decay we're talking about, plus the new element, the nitrogen 14 with its 7 protons. Okay, so that is how we would write out the equation. All right, so when you do this decay, you do the opposite of what that says. Do the opposites. It's not -1. It's add 1 to the atomic number. Okay, so another example, just very, very quickly, because I don't want to give you too much on this, to be honest, because I just want to let you get on with the examples and things and just get stuck in, and there's Seneca to work on today as well. We've got Ra, which is radium. So radium 228, 88, and that undergoes beta decay as well. So I'm going to write my beta symbol in. Ooh, the tail's not big enough there. Plus that becomes actinium. So AC 228, 89. So my masses remain the same, but we can see my atomic number has increased by 1. Okay, so another example really quickly, and then I'm going to kind of leave it there and let you guys just crack on with this. Polonium is 218 and 84. So we've got radon 218, again masses stayed the same, 85 plus our beta decay. Now I've written that a slightly different way around. That's just because I'm reading an example, and it's just so you can see you can write it whichever way around you feel comfortable with. It's entirely up to you. Either way will be accepted by the exam board, so don't stress about which way around you've got to do it. Either of them is absolutely fine. Okay, so you are going to have a worksheet with some beta decay examples on, and then you're going to have a worksheet that's got alpha and beta all combined all the way down. Okay, just be very careful with it. If you want to do it on a separate sheet of paper and write it out and then send it to me, that's absolutely fine. But just take it easy, see how you get on, and just let me know what's going on. Okay, enjoy and have a lovely Wednesday.